So we'll move on to our next talk. We have Thibault, sorry. So Kate's going to talk to us more about open data and fair use and approaches to using data. So without further ado, let's welcome Kate.
Thanks, everyone, and many thanks to Scott for all of that. Like everything he said times 1,000 is also what I am working towards in my career. So that was a great lead-in. So I am focused as, let's see, should be there, right? Yes. So I lead the science team at the National Science Foundation's National Ecological Observatory Network, or NEON. And so a couple things today. I want to start off by making y'all aware of NEON, because I'm sure some of you are not. But I won't belabor that. I also just want to talk about how we as a large data provider adhere and embrace and champion fair data principles. And I want you all as data users, you're all data providers as well. It's just a matter of scale, right? In terms of thinking about all of how you can adopt these practices in your work. And I think the mantra of citation is hugely important, because as Scott said, that is not a practice that data users have necessarily embraced. The way our funding agencies really need you all to embrace it so that they can continue to provide the resources that you rely on. So that's my little soapbox there, but I'll keep going here. So NEON, as I said, it's a National Science Foundation project. It's a large facility, so akin to a telescope that they might fund, but it's a telescope trained on the Earth. So it's continental scale. We do provide open data to advance regional and continental scale understanding of ecosystem processes and environmental change across the US. So we are a user facility in the DOE terminology, but I think it's a good one. We provide more than 180 publicly available data products, just via an API on the internet. You can have at them. We collect them using standardized methods so that the data are comparable across space and across time, with the plan to operate the observatory for 30 years. And we started full operations in 2019. And we've distributed the sites through these 20 ecoclimatic domains that are depicted here, and that's a way to enable scaling from the site scale to the continent. So to give you a few more details about the observatory, we're going to do what we like to call a virtual walk around. So we're going to start with our instrumented systems. So we have flux towers at each of our terrestrial field sites. So these are very similar to Ameriflux towers that I'm sure some of you are aware of. Essentially, we have a lot of sensors at a bunch of different levels above the ground that measure many different aspects of the atmosphere: barometric pressure, carbon dioxide flux, and a variety of other things. We also have plots nearby for ground and below ground measurements, soil arrays and through-fall instruments that can be used to study things like heat flux, nitrogen cycling, and other things. Our aquatic sites are also fully instrumented to collect data on freshwater ecosystems from streams to larger lakes. And there are lots of aspects to our instrumented systems, and I'm not going to go into all of them here, but here's some examples. Our PhenoCam, which are automated cameras to track the timing of vegetation activity. We also have groundwater well stations and MET stations, and they're all maintained and monitored by our distributed teams of field staff, like you see here. So we also have mobile units of our instrumentation that researchers with funding, is the important point there, can request to deploy to anywhere in the US for their own purposes, like that burn you just saw. So our observational system, these are data collected by field staff rather than sensors. And again, they're trained in standardized protocols across the continent. They sample soil, water, and a diversity of taxa, so plants, animals, microbes, lots of things. And each domain has a central facility for sample processing. A lot of samples get shipped to analytical facilities, and a lot get shipped then to what we call our biorepository at Arizona State University, so where samples are curated and ready for PI-driven research. And finally, our airborne observation platform. These are planes equipped with instrument payloads that collect ecological data from the sky. Our Twin Otter aircraft carrying the payloads fly low and slow over about 100 square kilometer footprint over our sites, and they're collecting hyperspectral, LIDAR, and camera imagery. And with these remote sensing data, we can generate these really high resolution images over our sites. And we do this during periods of peak green every year, again, for comparability. And this data in particular, I'm sure many of you know that it is a challenge to work with. So we do a lot of processing to create research-ready products. So all of these data, of course, are integrated and integral to NEON and are all open and available. So hopefully all of you who are working on tackling a lot of our important environmental questions can take advantage of those. Oop. Nope, nope. Now, how do I get to the next slide? What's going on? Oh, there we go. Okay, so sorry about that. As I said, you can get all of our data through an API. We also have a data portal, which is very helpful for exploring the data. But even when you are sampling repeatedly for years and years, even our smallest data products have a lot of records in them. So generally, we have a lot of tutorials on our website. Again, these are trying to help folks really dig in quickly, and those rely primarily on programmatic approaches, given the quantity of data. Right now, we have a NEON Utilities R package that is extremely popular for helping to manage all of the data we generate. We are in the process of making a Python one, so I know many of you in the room would appreciate that. So to step back a little from just NEON, right? NEON has been in people's minds for decades at this point, even though our operation started in 2019. And it was envisioned right in this era that fortunately, at least Scott and I are very happy, that the world has embraced this idea of open science. And in fact, and NEON was always envisioned to be an open data provider. That has never been questioned. And since the design era for NEON, we've had the federal government even really stepping up and stepping in here. And so we see from our White House's Office of Science and Technology Policy, we see sort of increasingly stronger language in their memos about this. So in 2013, their memo was encouraging federal agencies to increase access. And then in 2022, we had a memo about ensuring free, immediate, and equitable access to open data. So it's coming for you. So we are, I'm glad there are events like this to help people be ready for it. Because of course, then they announced this year as the year of open science. NEON is excited to be a part of that landscape. And as Scott introduced, we embrace FAIR principles. So findable, accessible, interoperable, and reusable. And I'll talk about a little bit more. So findable means essentially machines can find your data in an efficient way. And that typically requires globally unique identifiers and robust metadata that is in standardized formats. Accessible, and this is being available on the internet, is one small piece of accessibility, but there's a lot of aspects to it. Interoperable, of course, means that your data can then work well with other data to enable synthesis. And reusable means essentially that core principle of the scientific method that we still haven't quite mastered, which is making all of our analyses repeatable. And so we have taken a number of approaches to try to help our users to have reusable data and therefore reproducible analyses. So for findable, of course, we do lots with identifiers I'll talk about. As I said, we have our data available. Our license is actually the least restrictive license. So we're a CC0, which means we're just in the public domain. But that does not mean, that is to encourage the most open and accessible data, as is our mission. But that doesn't mean we don't expect scientific norms to be used in that people actually will cite our data. This just makes it easier for our data to end up in lots of different places and is the recommended open science practice. But that doesn't mean you shouldn't cite the data. So I'll say that a few times, I'm sorry. And then also for interoperable approaches, we rely on several different standard vocabularies. For any ecologists in the room, there's probably not too many, but there's not an abundance of standards for a lot of the data, and so we do what we can there, and we are actively collaborating to help fill those gaps where we can. But that's a community-driven process. It has to be, and there's a lot of work still to be done. And we serve our data through other portals, and I'll talk a little bit more about that too. For reusability, we have a lot of documentation, which we realize is also quite painful for the users, but it does allow folks to know how the data are being generated. At least that is the goal. We go a little bit beyond FAIR by also providing some guidance for our data users on how to generate FAIR data, so we'll talk a little bit about that if they're using NEON data. And I understand you heard more about this yesterday. One of our NEON scientists, Katie Jones, is a PI on an NSF award that is starting to explore how we might be able to apply and adhere to care principles for Indigenous data governance. That is a big question, and there's a lot of work to be done there, and so we're excited that that effort is starting. Okay, so here's some nitty-gritty stuff when thinking about FAIR data. Those globally unique identifiers are very important. The digital object identifiers we provide for our data product releases, which I'll get into. Our samples have many identifiers. So as I mentioned before, we actually collect upwards of 100,000 biological and environmental samples every year that we send to the biorepository. So there's a lot of science waiting to be done there, and all of those samples get a number of identifiers, and we've adopted the international generic sample numbers. IGSN and DataCite and ORCIDS are all, I'm sure you're all familiar with them. They're global organizations, so they really will hopefully help ensure uniqueness and sustainability of those identifiers through time. We do include ORCIDS for all of our field staff in our data. And that's a way of both giving them an opportunity to get credit for the work that they do, as well as actually enabling folks to also examine the data for potential observer effects, which is a common issue in taxonomic data, for example, identifications potentially varying across people and the like. So there's multiple uses there, but that's fantastic. We also encourage folks, right? We provide code packages. They are all, open source, of course, and available. And again, we've had a heavy emphasis on R because of our community, but we understand the importance of Python. in the world. And our remote sensing team, of course, is a heavily Python-based team. And so we do have those packages available there. And we encourage folks to contribute to the Code Hub to help folks discover code that people have generated using Neon data so that everyone's not recreating the same wheels. We have a really hard time getting contributions to this, even though we know a lot of people working on code using Neon data. And so I think these are some of the questions that I always like to ask people in terms of what are your barriers? Why don't you want other people to know? And a common answer I get is that they want it to be done, right? They're waiting for the code to be done. Which, yes, I think laughing at that is appropriate. There is a point, right? Obviously, you don't necessarily want to commit one line of code and share it on a website. But I encourage you all as users to think about that and to try to get your code out early and often, even though I know it can feel very vulnerable for those of us who have not been trained as a proper software developer. But that's probably not a lot of you. You all have good skills. And again, the tutorials I've mentioned. We do partner with other repositories, and so those include Ameriflux, so folks can get all of our data through Ameriflux as well. So that's sort of the peak of interoperability there, and a variety of other networks. And there's a lot of benefits to this, right? So it increases discoverability for folks that just use these systems and might not know about Neon. But a lot of these folks also generate value-added products to our data that are not in our technical scope to generate. So we are actively working to increase the number of partners. These kinds of, when you're working with data aggregators, the big challenge, of course, is the citation and the traceability and still maintaining credit. But we are embracing sharing as much as possible. But I think as a data user, these are interesting things to think about. So as I mentioned, we have extensive document libraries. So, if you're planning on doing any macroinvertebrate sampling, here's a guide to how you might do it. We have a lot of these, and they're all on our website. So it's another part of thinking about, our methods sections are rarely really long enough for anyone to actually go out and do your work for you or do it again. And so that is sort of the goal that we've been working on. So they're fully open. So our data releases, this isn't as standard of a practice, but we started doing this in 2021. So every year, each data product gets a release associated with it. And this is essentially just a snapshot of the data at that point in time. And it gets a DOI, and the plan is that we are going to store it for the lifetime of the observatory, so that anyone at any time can go back and repeat the same analysis. There's a little bit of a lag time built in. It's not all the data up to a certain point, because the idea is also, which I'll get into. Let me just say first, this doesn't apply to our remote sensing products, unfortunately, because they're so large that it's cost prohibitive to store multiple copies of those data. So we are tracking other aspects of the provenance of the data lifecycle in that process, but not the data itself. So this is our general timeline. So we like to get data out there as quickly as possible. But remember that, and we have a lot of built-in, into our data processing pipelines, automated quality controls. So we have a lot of confidence in the data that we're putting out, but I think we all understand that we also need some time, and having humans in the loop of quality control are very important, but requires some time. And so we refer to the data that are not included in a release as provisional. And so that is intended, so I know other data providers use similar language, but not all of them. So we like to think of those as, use with caution. They may change at any point if we find a quality issue that we need to either flag or correct. But So that this is all part of the release process every year. So we invest quite a bit of resources in this process, which is really to enable reusability more than anything. And so there's a lot of quality review that happens before we then go into we do it every January at this point. As I said, starting in 21, and we'll follow it up in 2024. So every data product gets a DOI, a new DOI every year that is resolvable to the exact data that we have in our database, as long as it's not a remote sensing data product. And these are, of course, extremely helpful for enabling our users to properly cite our data, the use of our data. So we do what we can on our website to really help users do that. Then we can use things like dimensions and altmetric software to track that use so that we can inform our funders and Congress people that people are using these data and that we should keep collecting them. So it's super important. Here's just a nice, and then we also get insights, right, into what are the products that are most interesting to people. So some of our most used products, you may not be able to read that, I apologize, are our vegetation structure and our LiDAR products. So really understanding the structure of vegetation across the landscape. Obviously has a lot of applications. No one is surprised by that. So again, cite the data. And fortunately, citation does appear to be improving. We've been trying to improve the ease with which our folks can do this. And then finally, so how we want to support our community to be fair in supporting outputs. I think the basic thing, there are some really basic approaches, and of course a lot of journals and now funding agencies are going to require that you all do this. And it's putting your code and your data package into a reputable repository. Citing data that are in the data package appropriately. So because our provisional data, from a NEON specific use case is subject to change, we recommend that if you're going to use it in your research, that you actually store that part of the data as part of your data package so that it is in fact repeatable. We've been working, if you're familiar with the National Science Foundation's Environmental Data Initiative, we work very closely with them. They serve a lot of other ecological data sources, so it's a natural partnership for us. And we're open to, as I said, more and more partnerships in this vein to enhance discoverability, to enable folks doing NEON-related research to, essentially use similar tools that they're already used to for sharing their other data sets. And then, of course, there's a lot of emerging and challenging input issues that we probably can learn some more from some of the folks in this room about how we might better manage. There are, data sets that change every single day, and so how do you manage that? And there's the increasing size and volume of data that we're dealing with. And, data storage has gotten cheaper, but I can assure you it is not free. So that is, when you're generating, 600 terabytes of remote sensing data every year, it is far from free. So these are all concerns to think about. All right, well, that was my information thrown at you. We at NEON we want to be a leader in fair practices. We want to help people in their research do that, so we are open to feedback on how we can do better and what we might be able to do more broadly. And so these are some open questions if folks have thoughts on it, and what might data users do more of to ensure appropriate use. And what are the challenges inherent to all of that? What do you all run into when you're considering sharing?
So I think one of the challenges that I've noted, obviously, when you're trying to use data that have been collected well before we were thinking about fair practices and things like that.
Yeah.
The challenge of now kind of almost going backwards and doing this with older data sets, or data sets that were collected by some group that then wants to be able to contribute in a way, and do we have those mechanisms to work through, which would be a laborious process and definitely not free from people's time on any stretch of the imagination, on an organization side, on a scientist side, for then working towards getting something that then is as set as can be, in the limitations of what we have. And so one question that I had was, Neon basically produces all this data itself. Mm-hmm. Is there a mechanism, or is there a thought about the ability for the community to contribute that Neon would then, through agreements, manage?
It's a great question. Yeah, it's a great question, and we get it quite frequently. And so this is part of our partnership with the Environmental Data Initiative. And so it is more set up to be a broad repository of data. And so that's sort of the, part of the reason for our collaboration is if we can motivate and inspire folks who are doing Neon-related work to store their data there, it's a lot easier for us to make it more discoverable, right, through our tools, and generally just help everyone out in that process. So that's we see that more aligned with their scope, and so that's why we've been partnering with them. I mean, these are things we think about a lot, right? One of the challenges, of course, we generate a lot of what we call level 1 data, right? They're not very well processed. And so it requires a lot of work and skills to be able to turn them into something ready for research. So we've been considering all of these challenges, and so that's the method right now. But it's interesting to think about because I think it's the same, folks do a lot of work to generate code. Making it operational in a context like Neon is a whole nother hurdle that is not free. And so these are the sort of challenges we think about. And then the Neon model as well is for our data products. No one's name is associated with those data products. Of course, I know who made those data products. There are people, in fact, highly responsible, and with Tanya being one of them. But we don't have that system, and so there's benefits of using other systems like EDI, where a person's name, you can get a resolvable DOI that can be cited and credit given. So there's no clear answer, I don't think, to that. Scott?
Add on that as well. DOIs with the person's name who worked on that is really important. But what we're also doing in another project we have, which is called Crocus, is really encouraging our folks to write short meta papers on that, or write a paper that kind of talks about more overarching things. Because, as we said, there is a lack, there's this culture of not citing data sets, but often we find if we have a paper out on it, it's much more likely to gather citations, which is, I know it's kind of feeding the beast, but it's dealing with reality as well.
Yep. Yeah, that's a great point, Scott. And right, all of those mechanisms, right, there are a number of mechanisms now that folks can do that, which is fantastic. And linking to a repository is also very helpful. Yep.
It seems like you have a ton of data. Would you say that your file types are cloud optimized? Like, are you moving stuff to like ZAR and cloud optimized geotiffs, or like how is computing is going to change where things can't fit on our laptops today? So how are the data repositories changing in light of that?
That's a fantastic question. So we actually just migrated all of our storage to the Google Cloud in the last couple of years. And so I wouldn't say that anything is cloud optimized yet. We are working on that though. So we are actively putting our data into Google Earth Engine, our remote sensing data, I should say. So those will be cloud optimized geotiffs. So stay tuned for that. You should be able to find those. Our first sites should honestly come online any day now in the public data sets page, and then we're working on getting more and more data into that. The ecological community, I'm not sure how many of you identify that way, as I've said, but I know I'm out of time, sorry. There's not a lot of experience with cloud computing approaches. And so we have been actively, so I really appreciate the question because we're actively trying to engage with people who do use them to know what they need. And so we have a few power users that have given us some great feedback, but we're open to hearing more about the workflows that people want. And being very sensitive to providing platform agnostic tools and file formats as opposed to just Google all the time. So thank you for that. There's a lot to be done, but we're started, so I'm very excited about that.
So usually at this point I'd open the floor for questions, but Kate did a great job of that. So